talk to you about Unit 2, Matter, Lesson 6, Molecules. So we're going to be discussing atoms, molecules, elements, and compounds. To start off, let's discuss outer shell electrons. So the outer shell of electrons are the ones that form bonds with other atoms. Okay, so when you're looking at this outer shell, you can see that there's one electron in this outer shell. So we're looking at potassium here. Alright, you can see the inner shells are full, and that outer shell has one electron in it. When you're looking at a molecule of water, so we know it has two hydrogens and one oxygen. Alright, you can see that the two hydrogen are bonding with the oxygen with their outer shell, those valence electrons, alright? So atomic bonding determines the chemical reactions that occur among elements. So we know that this outer shell contains the electrons. We know that the electrons are the ones that are responsible for the chemical properties. And when we're talking about that chemical bonding, it is the atomic bonding that determines the chemical reactions that occur among elements. So, atomic bonds are important in determining chemical, physical, and biological properties of matter. Chemical bonding is the combining of atoms to form molecules. So you have these individual atoms floating around. You know that these atoms combine via chemical bonding to form molecules. Atoms can share or exchange electrons. So when they combine with those outer shell of electrons, they can share or they can exchange electrons, allowing each of the atoms to have a complete outer shell, because that's what they want. So these atoms want their outer shell to be happy, and what makes them happy is when it's full. Alright, so that's what they want. They want that complete outer shell. So they're always looking for another one to get with to have a full outer shell. The atoms of this molecule stay together by chemical bonds. So you have these two hydrogen atoms. They combine to form a hydrogen molecule. So that's H2. So each of the two hydrogen atoms has a single electron, and the outer shell of each hydrogen can hold only two electrons. So that means alone it's not full. But by forming a chemical bond, those two atoms share those electrons, and they both end up with a full outer shell. So in this example of hydrogen, there is only one shell of electrons for each atom of hydrogen. Alright, let's talk about chemical and physical changes. Chemical changes are changes in matter that involve changes in the types of molecules present in which bonds between atoms are broken and or formed. Okay? So then you have a physical change, changes in matter that involve changes in the relationships among the molecules. So there's the difference. This one is changes in types of molecules present. Physical change is just a change in the relationships among the molecules and or in their motion, but not in the compounds or elements present. So on the left hand side of your screen you have a picture of a burning match. So before the match started burning, it was still a match, but then you inhibit that chemical change. The match burns and there's no going back to its state before it was burned. On the right hand side you have a picture of a physical change. In the left beaker there's water, in the right beaker there's ice cubes. It's a physical change because those ice cubes can turn back into water. Okay? Here is a YouTube video that discusses in further depth chemical and physical changes. So it explains examples of chemical changes such as burning, rusting, or digesting food, and then It also explains and gives examples of physical changes, such as the ones we just discussed, melting of ice, boiling of water, folding, and cutting. Alright, so what about an iron nail? How does it become rusty? Alright, so we're talking about the chemical change of an iron nail. And that iron nail goes through a chemical change when iron in the nail combines with oxygen in the air to form iron oxide. So in this picture, you can see if we were to expose these iron nails to just water, no air, it would not go through that chemical change because the iron in the nail combines with oxygen in the air to form that iron oxide. So the compound forms with a chemical bond between the elements oxygen and iron. Alright, so that's where that iron oxide comes into play. And the chemical formula for iron oxide, I'll put that on the screen. So you can see that the chemical formula for iron oxide is Fe 2. Try to make it the same size for you. Oops. It's Fe2O3. That's the chemical formula for iron oxide. Alright, let's talk some more about H2. An element is made of only one kind of atom. It can be made of a single atom, or it may consist of two or more atoms bonded together. Now, some of these elements found in nature exist as molecules. Alright, so you have these two hydrogen atoms. Just as we discussed earlier, they share those electrons to form an H2 molecule. In nature, hydrogen exists as a molecule with the chemical formula H2, so it is a naturally occurring molecule. Compounds are substances containing atoms of two or more different elements. Okay? This one kind. Okay? Compounds are substances containing atoms of two or more different elements. Can you think of some compounds? What are the atoms of those compounds? One that I can think of is this H2O2. We all have hydrogen peroxide in our house, so it's not something that's real foreign to us. It's easy to relate to. So if we're talking about hydrogen peroxide, what are the atoms that make up that compound? Well, it's two hydrogen and it's two oxygen. Alright, so when you're thinking about something that may seem complex, hydrogen peroxide, it's easier to, when you see it, to break it down. And you can say two hydrogen atoms bond with two oxygen atoms to form hydrogen peroxide. There's a little note down here. So remember, a molecule of a specific compound will exhibit all the properties of that particular substance. Very important. A molecule of a specific compound will exhibit all the properties of that specific substance. Important to remember. So when you go to take your Unit 2 Lesson 6 test, you can refer back to this video. Make sure you're taking good notes. If you have any questions after you take your Unit 2 Lesson 6 test, your assessment, give me a call, send me a K-mail, anything at all. If you don't pass it, let me know. We can meet together and go through this again, go through a little more in depth, or we can I can put you in a breakout room. You can take your test, and then if you have any questions, you can raise your hand. That's all I have. Good luck.